Hello and welcome back. The block is still here. I spoke with a machine shop and we're about a week or two out before they can take it in. So I thought I'd make a second video here and get into the machining processes, how they're done, what to do first, proper orders, different things like that, what you're working with, how you want to do it, and things like that. So here we go. This is a factory 440 block. If you haven't seen my last video, check it out. We put billet steel main caps on it. So when you're starting out with an engine block, one, you need to determine the power level that you want to make. You know, this one we're hoping to make anywhere between 600 and 700 horse, give or take. Factory block should be adequate for that. We thought about using an aftermarket block, Keith Black or Mopar Performance block. But at the time, they were not available. So that was back just kind of after COVID. So we got this block instead, and we put billet steel main caps on it. We took the original main caps off, we put those on, we had them machined. So once you've decided what you want to do for a block, if you're going to use the factory main caps, they have to be the original caps that were machined to fit the block. You can't just take caps from another block and bolt them on. So now if you're going to use the original caps, you can probably get away with an align hone. If the block's in good shape, you can check the bores for taper, round, and alignment, and if everything works out, you could forego the align hone. I usually align hone everything. I just have it done that way. We have a fresh crank center line to work with. Especially if you're going to change fasteners too, you want to have the align hone done. But if you're going to use factory bolts, factory caps, and you want to save a little bit of money, you could check the bores for taper and out of round, and you could check all the bores for alignment with a round straight edge. If everything checks out, you could move on from there. Like I said, I like to at least do an align hone if we're starting out with the factory caps and factory fasteners. Now when they align hone a block, what they do is they put the main cap into what's called a cap grinder, and they grind off the mating surface. They grind maybe 3/1000ths or so off of that surface. And what that does is that closes this housing up. And then they take a long honing mandrel that goes all the way through, and they hone all of the housings back to the proper spec. They're not boring it to a larger spec. There are cases where you could bore it to a larger spec and then you have to use special bearings, but you would only do that if the block was heavily damaged as far as the mains go. So that's how they align hone a block. Like I said, they cut down the mating surface of the block, make sure that everything meets up real well here. They torque the fasteners, and then they hone them out to size, and they check them as they go to make sure. Now in this case, these are aftermarket main caps, and when you buy these, the manufacturer realizes that they're not just going to directly fit onto a block. So what the manufacturer of the cap does is they leave extra material in the cap itself, and that extra material leaves a lip right here that would break the honing stone. So you can't just align hone it. So what the machine shop does is they use a boring bar, and they go through and they bore out the extra material in the cap to make it align and fit to the block. Now they don't take a whole lot of material out of the block. They're just taking the extra material out of the cap. And once they've done that, what they do is they go in and they run the hone through it, and they bring it out to the proper housing size. So when you look up housing size for, say, this, which is a 440 big block Chrysler, your housing size will not change. We're not boring it to a larger size. We're just boring the pieces to make them fit, and then we're honing them out to a standard housing size. We're not going oversized with the housings. Like I said, there are cases where you can go to a larger size, but it's fairly rare, and you have to make sure that the bearings are available before you do it. A block like this, I don't know if you can get oversized outside diameter bearings. But it's not really widely done. The people who usually do it are mass engine rebuilders, like crate engines, the remanufactured engines, I should say. They'll do stuff like that because they're looking to just get it out the door, get it fixed, and get paid. So this one has the steel billet main caps installed and fitted. It was a line bored, and then it was a line honed. Now that gives us a true crank center line to work off of, because all of your machine processes should be based off of the crank center line. So first thing you want to do when you get a block, you want to clean it, you want to check it for cracks, and the first machine process you want to do is you want to align bore, align hone, check whatever, however you're going to go with it. You want to do the mains first, because every other machine shop process that is done is going to be based off of this crankshaft center line. So this has to get done, has to be the first thing to get done. Now this block in particular, the next process that we got into was we bored the lifter bores to their proper locations, and then we had bronze sleeves put into those lifter bores to correct the size. So the lifter bores were bored out to a larger size, and their location was corrected to keep timing correct from cylinder to cylinder. And then the sleeves were put in to keep them at the original .904 size for this block in particular. Now there are blueprint specs. Blueprinting, I'll touch on this a little bit. Blueprinting is a very, should I say, a misused word when it comes to engine building. When someone says, oh yeah, I have my block blueprinted. Well, you had your block machined. If you had it blueprinted, believe me, you paid for it. Boring, decking, a line honing, or a line boring does not necessarily mean that the thing has been blueprinted. Bush fitting the lifter bores like this is a blueprinting process, because you are putting the lifter bores in their exact perfect location. And there are blueprints available for different engines. I don't have one for a Chrysler, but I do have one here for a small block Chevy. And you can see when they engineer these, they engineer them that the bores, the lifters, the block, everything is in the right perfect location. Well, when it comes to mass production and getting it out the door, close is good enough. You know, they're not perfect, especially back in the, you know, the 60s, 70s, 80s when they were making these. If it was close, it was good enough. So you can see here that we have our 0 is based off of our dowel pin, and then on your XY axis you can see the center of the cylinder, you can see the lifter bores, you can see the front of the block here where we have our exact 90 degrees between our cylinders. Our decks are square, perpendicular to the cylinders, and from the factory that's not always the way it's done. You know, they try and get it as close as they can. And newer stuff, the quality control has gotten a lot better. You know, if you're looking at LS engines and things like that, and you're making these measurements, they're probably a lot closer than, you know, the old small blocks or these old Chryslers were, because their machine processes have gotten better. So, now, the next process you could do to make the block correct, is square deck the block. And what you're doing is you're making sure that the block deck is totally square to the cylinders and to the crank center line, meaning that you have a perfect 90 degrees and a perfect 90 here, perfect 90 here, perfect 90 here, 90 here, 90 here. You're also correcting it from front to back. So in the front here, now the stock deck height on this is 10.725, and I don't have a way to measure it, but it could possibly be 10.723, and back here it could be, say, 10.726. It could be off. So when you square deck it, one, you're making sure that it is square this way, and you're also making sure that it is square this way from front to back. So that helps with all of your pistons coming up to exactly 0 deck. Next thing you could do is bore and hone your cylinders, which is a fairly common practice with a used engine block. Now the way they bore and hone a regular block, non-blueprinting, they will center up off of the bores, and they will run the boring bar down through, and they'll leave themselves roughly about 5 thousandths to hone and finish hone the bores too. So another way you could do it is you can put a plate, a blueprinting plate onto the deck of the block. And that centers off of the dowel pins. And what you do is you center your boring bar off of that plate, and then you bore your hole. The problem with doing that is there's casting shift when these blocks are made. And as far as small block Chevys go, sometimes they have to end up going to 40 over or 60 over, not just 30, in order to clean up the cylinder and put it into its correct location. So it gets expensive. Some blocks may not clean up if you try and blueprint them if they're factory, depending on how bad they were when the factory made them. But that's how you would blueprint. And lifter bores, cylinders, square decking, that all constitutes for a blueprinted block. You start to wrap some money up into doing that. A lot of guys won't spend that kind of money. They'll just buy an aftermarket block. An aftermarket block, you'll spend, for a cast iron aftermarket block, you'll spend anywhere from $2,000 to $4,000, depending on what you're buying. And those are small block Chevy prices. If you're working on an aluminum block, well, now you're probably looking at $5,000+ to get one. So, but what you're paying for, you're not only paying for a stronger block, you're paying for a block that is correct. The decks are correct, the cylinders are in their correct location, the lifter bores are in their correct location, the mains are correct, and generally they come with stronger main caps. You don't have to buy these caps and have the block align board. You may have to finish align hone them, and you may have to finish hone your cylinders, but for the most part that block is pretty much ready to go. Now, machine shop prices these days, that might be the way to do it if you want a blueprinted block, a block that's absolutely correct. So in this case, we're pretty close. I wouldn't call this a blueprinted block because the cylinders haven't been corrected. We did correct the lifter bores, we did put better caps on it, we did align hone and align bore the mains. It's close, but it's not, like I said, the bores are not corrected. And I think that blueprinting is a very misused term as far as engine building, as far as selling a block. A lot of guys like to say, it's balanced and blueprinted. Well, just because you made sure that your main clearances and your rod clearances and your oil clearances and your zero deck piston and all that stuff, just because you made sure that was right, doesn't mean you blueprinted it. Blueprinting to me is correcting the location of the lifter bores, correcting the locations of the cylinder bores, square decking the block, making sure that it's right. Factory connecting rods, if you recondition them, well, you've already moved away from blueprinting, because when you recondition a connecting rod, and I'll go over that in a later video, when you recondition a connecting rod, what happens is the rod becomes shorter. So, and in gasoline engines, they don't really correct the length. The rod comes up 3 thousandths, 4 thousandths shorter than it was from stock. Your piston sits 3 or 4 thousandths down in the deck, and that's pretty much accepted. The engine will run. I mean, it may not run as good as it possibly could, but anymore, people don't recondition connecting rods. They just buy a brand new set, because cost-wise, that's way more effective. Piston-wise, you want to buy a good set of pistons that you have the same compression height all the way through. So when you're assembling this block, if number 1 comes up to 0, with good parts, every other one should come up to 0. Good parts, good machine work, different things like that. So machine shops with better equipment can usually do a better job of this, but I don't want to discount a good quality machinist, even if his machines are older. If he knows what he's doing, you can definitely get it right. But if you're looking to blueprint a block, there are specs. And if you start measuring this stuff on a factory block, you'll find it's probably not right. The older it is, the more likely it is not to be correct. So the newer it is, the better. Engineers blueprint it, and that's where the term blueprinting comes from. They don't just throw together a sand mold and dump in some cast iron or some aluminum and see what comes out, and then just all of a sudden start machining it and go, oh, look, we got an engine. No. They design it first. I don't care if it's Honda, Toyota, Chrysler, Ford, Chevy. It all gets designed firsthand. So once it's been designed, they run it into production, and there are tolerances when it comes to production. And if it falls within tolerances, and depending on the manufacturer, I know Chrysler was pretty bad compared to Ford and Chevy back in the day. Their tolerances were a lot bigger. They would allow for a lot more. Their blocks are not quite as good. But there's things like that to take into consideration when building your engine. But like I said, first thing you want to do is get a true crank centerline to work from. And all the other machine processes, boring the cylinders, decking the block, doing the lifter bores, all of that stuff should be based off of your crank centerline. So now another process to consider after the block has been aligned, honed, aligned bored, however you need to do it, with the fasteners that you want to use, square deck it, bore the cylinders out to the size that you want. Most guys only go to about 30 over. The next thing that is done is you want to have it plate honed, and what the machine shop does is they bolt a torque plate onto the deck of the block. And you want to use the fasteners. If you're going to use head studs, you want to use head studs. If you're going to use head bolts, use those head bolts. Put a gasket on, put the plate on, torque it to spec, and when you torque it to spec, it pulls the top of the cylinder out around. You also want to have your mains torqued when you do this, and you want to run your hone through with that plate on while it's torqued, and what it'll do is that out around cylinder will become round with the torque plate on it. Now when you take that torque plate off, the cylinders will go out around, but when you torque your cylinder head on, you will now have round cylinders, as close as you can get them to round. Some race teams, what they do is they'll put a torque plate on it, they'll torque up the mains, and they will run hot oil through the coolant jackets, oil that's roughly about 220 degrees, give or take, to simulate a cooling system and finish the cylinders even closer to the way that the engine will be when it's running. That's kind of tough, and I wouldn't do that for a street engine because the heat causes the cylinder to get larger. Problem with doing that is those race engines are fully up to temperature, oil and coolant, before they even start them up, so your clearances are right. But when that engine's cold, you have tighter clearances. You could end up scuffing a piston skirt, having problems with your rings, so on and so forth. Not something that I would really suggest for a street engine, especially because of all the different driving situations that it goes through. But torque plate honing is a good thing. And those are pretty much the block machine processes that are done. Hopefully in the next video we'll get to move on to some assembly, but I'm thinking I'm probably going to do a video about balancing the connecting rods, the pistons, weighing the rings, weighing the rod bearings and things like that, and setting up bob weights so that we can get the crankshaft balanced. So if you have any questions, I may not have been as thorough as I possibly could. If you have any questions on the processes, please leave them in the comments and I'll do my best to answer them. And if you like this video, hit the like button, and stay tuned for the next one. Thanks.